Hey everybody, let's spend a little bit of time predicting the products of a double replacement reaction. I would say most of kind of this intro chemistry reaction stuff is going to be double replacement or maybe even single replacement reactions. So let's talk about how to predict the products. Now, there's two ways to do this. Okay, the first way, okay, and I'm gonna show you only by examples. I'm not gonna give you notes on this. Okay, what I have is, just so you know, I have a worksheet here that we're gonna work on, but I have the first question from that worksheet where this reacts. Now, the first way that we are gonna do this is if we're given the name. Okay, we're still going to eventually have to write formulas, but if we're given a name, remember, a double replacement reaction is what I call a wife swap. So if I take the first element of each, the metals, and then swap them this way, I can write the products of the reaction. It's going to be, let's see, mercury 2 comes over here, mercury 2 iodide plus aluminum chloride. Okay. Now, that's kind of the easiest thing to do when we're given the names of the reactions, or the name of the reactants. Predict the products, switch the two, because we know that this is an ionic compound and this is an ionic compound, and so these things can do all sorts of good things. But that is the cheap way out, because there's another way to do this that gives you way more information and helps you go further into the chemistry than just coming up with the product. So if you want to do it this way to help you get started, that's fine, but I would suggest doing it this second way before anything. So in order to do this, what we're going to do is we're going to write the formula. And now aluminum iodide is Al(I)3. Aluminum is a 3 plus, iodine is a 1 minus. We can tell that, and so we know that the least common multiple is 3, so there's got to be 3 of those and 1 of those. Okay, great. Okay, and then mercury 2 chloride, same thing. Mercury is a 2 plus, chloride is a 1 minus, so this is going to be this. Now, the thing to keep in mind is that the metals are going to switch. So what I'm going to do is I am going to make, and however crazy this is, I kind of refer it back to Punnett squares, even though it's not really a Punnett square. It's what I think people know from biology. So what I'm going to do is I'm going to take the first reactant, it doesn't matter which one actually, but I'm going to take one of them, and I'm going to go aluminum, and I'm going to put the aluminum ion up here. And then I'm going to take the iodide ion and put it here. And notice I'm not putting the subscript here. I'm not putting that 3 in there. Okay? I'm not putting that in there because this is the iodide ion. We'll later balance this whole thing to get us the right answer. Okay, and now we're going to do the same thing with mercury 2 chloride. So this is Hg2 plus, and I would put the charges there, and then chloride is minus. And remember, you can use a periodic table to figure out the charges for the main group elements and things like that. Okay, so now in order to predict the products, what we're going to do is we're going to take this and we're going to combine these however we can. And so remember, chemically speaking, positive charges aren't going to attract each other. So aluminum and mercury are not going to react each other, and the same is true with the negative charges. And so there's not going to be anything that is there's not going to be anything that that forms when chlorine and iodine get together. But now what we can do is we can get Hg, okay, reacting with the iodide. So let's see. So over on the side here, this is Hg. This is a 2 plus. This is a minus. And then there is a 2 is the least common multiple, so we need a 2. So this is going to be HgI2, because when we make formulas, when we make the formulas of compounds, then we have to use the charges on the ions in order to do it. It's not the existing coefficient that's there. Okay, and then we can do the same thing with aluminum. Aluminum is a 3 plus. That's why I suggest putting the charge. And then Cl minus, 1 minus, the least common multiple is 3. This is a 3. This is a 1. So this is AlCl3. Perfect. Okay, so what we have now is we have predicted the products of this reaction, and we only have 2. Okay, so now we can go here and we can write the reaction is ALI, and I use a cursive L for my L's most of the time so that you can tell the difference between the L and the I there. So it's ALI, which we have there, plus HgCl2, and that reacts to form. And notice my arrows are lined up. Okay, I try the best I can there. And then we go HgI2 plus AlCl3. Okay, now this, then, the reason why I like doing it this way is because now this can lead into solubility and doing IC, or not IC charts, but doing net ionic equations and things like that. So let's see, aluminum iodide, is that soluble or aqueous? This is aqueous. Okay, and so I would write the state there. Okay, how about mercury chloride? That is a solid. That, remember, most chlorides are soluble except for silver, mercury, and lead. So that is a solid. That's not aqueous. That's not a solution. And the same thing here. This is a solid, and this is aqueous. Okay, so now what we can do is then we can go further with this because we've written the formulas out, and we can balance this guy. Or we could do the net ionic equation. Either one is fine. Let's do the net ionic equation. Let me show you how to do this thing. Okay, so the net ionic equation for this. Anything that is aqueous is going to get split apart into its ions. Again, another reason why I like this kind of semi-Punnett square thing is because aluminum, it shows the charges. So this is going to be Al. So this is the molecular equation. This is the total ionic equation. Okay, and so this is going to be Al, and then 3 plus I minus, and all of these things are aqueous because that's what the ions are. They're floating around in the solution, and this thing is a solid, so we don't split it apart. HgCl2. Now, one of the biggest misconceptions that students have is they think, hey, this is solid, so there's no reaction. That's incorrect. Solids will undergo a reaction. They just don't split apart into their ions. Okay, so then this is going to go solid plus Al3 plus Cl minus, aqueous. Okay, and this is aqueous. So now, in order to write the net ionic equation, okay, the net ionic equation, NIE, we cancel everything that's the same on both sides. So this is aluminum here, and those are the only two things that are the same on both sides. So now we have I minus aqueous plus HgCl2 solid reacts to form HgI2 solid plus Cl minus. And so now what we can do from here is we can balance this guy. It becomes a little easier to balance, maybe. Okay, so I'll go through balancing this thing just to make sure that everything seems okay. So let's see here. We need, and I'll balance in blue. Okay, for some reason I always like to balance in blue. So there's 2I. And then there's 1 Hg, there's 2I, and so there now needs to be 2 Cl minus. Oh, I forgot to write a state here, aqueous. Okay? So that's the balanced chemical equation. Now, up here, if we were to balance the molecular equation, let's see what would happen here. Let's see, there's 3 chlorines and 2 chlorines. So this needs to be a 2, and this would need to be a 3. So that would need to be a 3, and this would need to be a 2. So what can happen here is now when we do this, when we do the total ionic, okay, and I'll do that just in a different color just so it's offset. I'll do it in red. Okay, how many aluminums are formed when this is split up? It would be 2. And then how many iodines is 6? Okay, and then there would be 3 of these. And now there would be 3 of these. There would be 2 of these. And there would be 6 of those. And so what that does is that gives us 6I minus aqueous plus 3HgCl2 solid reacts to form 3HgI2 solid plus 6Cl minus aqueous. Okay? And so why are these two the same? Because this guy is in the lowest, has the lowest whole number ratio. Okay, so this is 6 to 3 to 3 to 6, which is a 2 to 1 to 1 to 2. So this is 2, 1, 1, 2. And so my guess is that you would rather do math with numbers like 2 and 1 than 6 and 3, even though the whole numbers, it's fine. So, so that's that sample problem. It gives you an idea of everything that's involved in what I'm expecting for this worksheet. So, yeah, there it is. Have a great day.